Assalamualaikum Dr. Sufyan, this is group 3 and we will be presenting our second group project for thermodynamics.
Hi, my name is Zafira Yazia binti Zainuddin. My metric number is BK23110362 and today I will be explaining about the introduction and also literature review of our project. Basically, the project is to design and analyze of a waste heat recovery water heater system. So why we need to design a new one instead of the traditional water heating system? Because we need to cut costs, promote sustainability, and also energy saving. So in this project, our aim is to provide a clear and concise documentation of our project objective, design decision, and energy balance calculation, and also do the recommendation for further improvement and potential application. So let's move on to literature review. The first one is problem statement. We think that traditional water heating wastes of energy and it will cause high bills and increase carbon footprint. Not to forget, appliances generate waste heat that is unused. So to overcome this, by develop a system that captures and utilizes waste heat for water heating. Next is overview. So we think that by creating this waste recovery water heating system, it can capture and reuses waste heat to heat water. And the application is to be used in home and industry. And the benefits, we can save energy and cost, obviously, and eco-friendly because it reduces reliance on fossil fuels and it will enhance the efficiency by converts wasted energy into useful heat. For heat recovery mechanism, basically the core mechanism of a waste heat recovery water heater system is involved by transferring heat from a waste stream, such as exhaust gases, hot fluids, or steam into a working fluid, which is typically water, and using a heat exchanger. Common heat recovery methods includes recuperator, heat pipes, thermoelectric generators, generative heat exchanger, and also phase change material. Next is comparison to traditional system. Traditional system, it is high electricity, gas consumption, expensive, and also polluting. But waste heat recovery uses waste heat, lower cost, eco-friendly, and more efficient. Lastly, for literature review is recently in technology. These are the technology that has been used recently. There are new heat exchanger, nanomaterial, AI and IoT, integration, energy storage, hybrid system, and also modular design.
So we decided to take the water heater system as our devices for this project. And the process starts with low temperature water entering through the pipe, then goes through the heat insulation pipe straight to the water heater generator. The water will be heated up and go to the shower. The high temperature water will end up into the floor sink. This is where the heat transfer process begins. The heat from the high temperature water will trap in the heat insulation. So, whenever water enters the pipe and through the heat insulation pipe, it will be heated up. From this, less power is needed to heat the water from the water heater generator.
Next, I'm going to present for the calculation part. We choose the FU form as the insulation. Since the water heater are steady system, so no accumulation of energy is needed. So we can rearrange the first law of thermodynamic formula as shown below. For the first step, we need to find the Q useful, where using this formula, the answer for the mass flow rate is 0.0164. Next, we can substitute into the equation, then we get for Q useful is 1.713 kilowatt. We need to find the Q loss. For the Q loss, we use the Fournier law formula, and then we need to find the area of the surface water heater. Then we get 0.0369 m square. We only substitute the value, then we get the Q loss is 0.0015 kilowatt. Then we finally can calculate the Q in, which is 1.0153 kilowatt. Then for the efficiency, we get 99.91%. For the monthly electricity cost, we assume that 1% shower 2 times per day. So we times with 30 days, it is 60. Then times with the energy needed to heat water. So the total monthly bill for the without waste heat recovery based on the DNB bill calculator website, which is 22 ringgit 44 cent. And with waste heat recovery, it is just 2 cent.
Okay, next, I will present about our water heater system impact on economy and environment. The economic impact of the waste heat recovery (WHR) water heater system is significant. By reusing heat from wastewater, the system reduces the need for extra energy to heat new water, which lowers energy bills for homes and businesses. In addition, this leads to long-term cost savings, especially in places that use a lot of hot water like hotels, gyms, and laundry. Although there is an upfront cost for installation, the saving on energy bills quickly cover it and then make it a smart investment. It can also increase property value because energy-efficient systems are attractive to buyers. Additionally, the growing demand for eco-friendly technologies like this creates new jobs in manufacturing, installation, and maintenance. Some governments even offer tax credits or rebates for using energy-efficient systems that add more financial benefits. Furthermore, using less energy means less reliance on energy suppliers, which can protect against rising energy costs. More than that, the environment impact of the WHR system is crucial for the ecosystem. By using less energy, the system reduces the burning of fossil fuels, which helps lower the greenhouse gas emission and fight climate change. It also conserves natural resources like coal, oil, and gas because there is less demand for energy production. Moreover, instead of letting heat from used water go to waste, the system captures and reuses it, reducing thermal pollution that can harm local water system and wildlife. Hence, this also helps reduce strain on power grids, especially during peak times. The system supports eco-friendly living by encouraging people and businesses to adopt sustainable practices. Thus, it helps improve air and water quality whereby less energy production means fewer harmful pollution in the air and cooler wastewater is better for aquatic life. Overall, the system helps to create a cleaner and healthier environment while supporting global efforts to reduce climate change. Thank you.
Hi, I'm going to talk about how we can further improve on the recovery system. So, firstly, we can enhance the heat transfer efficiency by implementing advanced heat exchangers like the microchannel, the plate heat exchangers, and other than that, we can also explore into nanofluids, explore other types of nanofluids to improve the thermal conductivity. Other than that, we can add on smart monitoring and automation. We can integrate IoT sensors for real-time system monitoring, and we can nowadays, as we move into the future, we can utilize AI-driven analytics for predictive maintenance and energy optimization. With that, we can also improve the durability and insulation. We can use corrosion-resistant materials to increase the longevity of the product, and we can incorporate phase change materials also known as PCMs, for better heat retention and storage. And we can expand this system's application. We can modify the system to work with more household appliances like the washing machine, the dryers, the dishwashers, etc. And we can develop a modular design for a scalability and adaptability. Last but not least, we can improve in terms of reducing the cost and increasing the adoption of the product of this waste heat recovery product by like optimize the production of the product to lower installation costs without sacrificing the efficiency of the product. And we could also encourage government incentives like subsidies or tax credits to promote the adoption in to bring more people to use the product that we are having here, the waste heat recovery system. And in conclusion, the effective energy solution is the waste heat recovery water heater system efficiently captures and repurposes heat waste from household appliances, and it reduces the energy consumption and it reduces electricity costs and our carbon footprint. And this system has a high efficiency, and we can achieve 99.91 thermal efficiency, demonstrating the significance of energy savings. And we reduce the reliance on fossil fuels, and we support the eco-friendly living. And this has a major future development potential, improvements in heat exchangers, smart monitoring, material durability, and we can even enhance the performance of the system. And we can implement AI and ITO integrations that can automate the energy usage and the system maintenance itself. And last but not least, sustainability and practical innovations. And this system can be applied to in both households and industries for the long-term environmental and economic benefits, because it is cost effective, it's scalable, it's eco-friendly, it's a solution for energy efficient water heating. So this is the conclusion we have come to with our waste heat recovery water heater. Thank you.